Now we've seen the centre of mass formula for two objects, and it's one you won't be given when you get to do a test. Now if you haven't already seen it, well you should have seen it, it's the one where we had the m1x is equal to m2 times d minus x. Works well for two objects, no problem, very good. But we actually have another formula that says the centre of mass, centre of mass is equal to x1, well we'll start with m1x1 plus m2x2 plus m3x3 all over m1 plus m2 plus m3. Now that is for any number of objects, that's why I go ... So if you've got 3 objects, 4 objects, 5 objects, that still works. So with that sort of formula, if I had all these objects, that could be a 5, that could be a 6, that could be a 10, and I ask you, where's the centre of mass of those 3 objects? We're not using the 2 objects anymore. Of course, we could use the 2 object formula, find out the centre of mass between these 2 guys, then treat it as 1 object, which we can do, and then we're back to 2 objects, and we could use that formula again, the top one. But we can do it all in one go, and we could just call this one M1, M2, M3. We have to decide a point to measure from, and that's arbitrary. You can decide any point you like. So if I decide that I want to measure from this guy, then these distances all get measured from this guy. If I had decided to measure from this guy, then this could be a negative distance and this could be a positive distance. So if this was 3 meters and that was 4 meters, then setting up the formula, measuring from this guy, we would say x is equal to m1 times distance from measuring point, which is 0, plus m2, which is 6 times 3, plus m3, which is 5 kgs, times the distance, which is 7, times all divided by m1 plus m2 plus 3. Now this one weighed 10, 16, 5, 21. I'm sure you can do the calculation. That will give you the distance from the point you measure from. And that's a general formula for finding the centre of mass.